Hello everyone, here is a question based on stoichiometric mole ratio. A 2 gram sample containing manganese dioxide is treated with hydrochloric acid liberating Cl2. The Cl2 gas is passed into a solution of potassium iodide and 60 ml of 0.1 molar sodium thiosulfate is required to titrate the liberated iodine. What is the percentage of MnO2 in the sample is? Let us first write all the balanced equations so that we can establish the stoichiometric mole ratio. We have manganese dioxide treated with the HCl and we would get manganese dichloride plus Cl2 plus water. We have 4 chlorine atoms on the product side. So therefore, let us multiply HCl with the 4. We have 4 hydrogen atoms on the reactant side. So therefore, let us multiply water with the 2. Now everything is balanced. And then Cl2 is passed into a solution of Ki. This would liberate I2 and we would also get KCl. We have to multiply KCl with the 2 so that we can balance the chlorine atoms, and we have to multiply potassium iodide also with the 2. So now this equation is also balanced. Now the liberated I2 is titrated with the sodium thiosulfate, that is Na2S2O3. This would give us sodium tetrathionate, that is Na2S4O6 plus sodium iodide. Now we have to multiply sodium iodide with 2 so that we can balance the number of iodine atoms, and we have to multiply sodium thiosulfate with 2 so that we can balance the sulfur atoms and also sodium atoms and oxygen. So now everything is balanced. Here the stoichiometric mole ratio is number of moles of I2 divided by 1 is equal to number of moles of sodium thiosulfate divided by 2, because we have the stoichiometric coefficient 2 here. So this means number of moles of I2 is equal to the number of moles of Cl2, and number of moles of Cl2 is equal to the number of moles of manganese dioxide. So therefore, the stoichiometric mole ratio is number of moles of manganese dioxide divided by 1 is equal to number of moles of sodium thiosulfate divided by 2. So this is the equation that we have to use so that we can find out the mass of MnO2 first, and then we can find out the percentage of MnO2. Now what is the number of moles of sodium thiosulfate? That is equal to molarity times volume. Molarity given is 0.1 molar, isn't it? And volume given is 60 milliliter. So therefore, this is 6 millimoles. So therefore, the number of moles of I2 is 3 millimoles. Therefore, number of moles of manganese dioxide is equal to 3 millimoles, isn't it? Because this is the equation we saw. So whatever be the number of moles of sodium thiosulfate divided by 2 is equal to number of moles of manganese dioxide. So that's the stoichiometric mole ratio here. So this is the number of moles of sodium thiosulfate. Therefore, mass of manganese dioxide is equal to number of moles of manganese dioxide times molar mass of manganese dioxide. Number of moles of manganese dioxide is 3 times 10 to the power minus 3 mole times molar mass of manganese dioxide is 87 gram per mole. So therefore 3 times 87, that is 261. So 261 times 10 to the power minus 3 gram. Therefore percentage of MnO2 is equal to 261 times 10 to the power minus 3 gram divided by weight given, that is 2 gram times 100. 10 to the power minus 3 and 10 to the power 2 we can cancel. We have 10 to the power minus 1. 261 divided by 2, that would be 130.5 times 10 to the power minus 1 percentage. So therefore this is 13.05 percentage. Therefore the nearest integer is 13. Therefore 13 is the correct answer here.